here what I want to show is, yes, so we have find weight dl by dwi. Here some optimization and solving has been done, so nothing that fancy. And now what we will see is how we can calculate loss with respect to weights of different, like we need to solve for output, then candidate state wg, and forward gate wf. We have to calculate for wi, wo, wg, wf. We need to calculate. Now calculating for wf, again we need to start from forward gate. You can start dl by dft, then dft by dwf. So dl by dft and dft by dwf we can get. By chain rule we will get all the intuitions of gradient descent you can apply, how backpropagation works, mainly those things as I've said earlier. Independent variables, backpropagation like this, and nudging the values of top and bottom, all those, and we will get the result something like this. And dimensions are always mentioned, already mentioned over here. And dl by dw0, like that means wo, output, we can get that by dl by dot and dot by dwt. It's like simple only, dl by dot and dot by dwo. So by chain rule we will get, and these are the simplifications which we have done. And the same goes for dl by dwg. We can start from here, dl by dgt we can start, and then dgt by dwg. Yeah, and dgt by dwg is nothing but ht minus 1, right? You can see this is a variable and this is a constant, so we can just write the constant itself directly. And here also I think it will be same actually. Here dot by dwo, ot by w, ht minus 1. Here also dft by dwf, ht minus 1. dft by dwf is nothing but ht minus 1. Actually we will also need to ask this also, because so here, and as you can see, gt by wg, dt by wg, we can get this only, this variable constant, so this we have got. And we also got 1 minus gt square here to that, so 1 minus gt square into ht minus 1. And here what happens is dot by dwo, we will get this, and dft by dwf will get this, dft by dwf we will get ht minus 1, and towards it ft of 1 minus ft into this. So here dgt by dwg we will get 1 minus gt whole square into ht minus 1, and here dot by dwo we will get ot of 1 minus ot into ht minus 1, this thing. And here dft by wf we will get this result, ft of 1 minus ft whole into like ht minus 1. We have to do like cross product, header mod, matrix multiplication over here, this thing. Yeah, now we will move to derivatives, gradients with respect to u next. Now we are going to calculate gradients with respect to u weights, input, candidate state, output, final. And again we need to have dl by d states, dl by d gates, which we have calculated. We can use here for calculating u weights also. For ui, dlt by dit, we can start from it, and again similar calculation how with respect to w, I, o, g, f, all those suffixes we are doing. And here as you can see, I am with respect to it, ui, dlt, whatever the loss with respect to it we need to calculate, then loss it with respect to wi. So that calculation we need to do, the next will come. Transpose we need to take for dimension of manipulation and managing. And again you can just check something like this, db bh, so it is dh, and again it is bh, so it will be bh, and so again you can check something like this, all this thing is bh, right? So bh, so all will be bh, and this will be db, it's not dh. And again now we will, because multiplication is these three and this one, and now we will get dh, and it is balanced with this. You can check for all equation earlier now also. you.